Hi everyone, my name is Makita Hansen. I am the Habitat Program Manager for the Utah Division of Wildlife Resources in southeastern Utah. Thanks for watching my presentation. Today I'll be talking about elk use of a box culvert in southeastern Utah and how we documented use through camera traps, GPS collars, and other technology. For a little background, the Utah Division of Wildlife Resources has what we call the Utah Wildlife Migration Initiative. This was founded in 2017 to document, preserve, and enhance movement of wildlife throughout Utah. Some of the main objectives of this initiative are to map stopover sites, bottleneck areas, movement barriers, and identify mitigation needs. Also, define critical habitats and strategically locate habitat treatments and evaluate habitat treatment effectiveness. And so we're documenting this through using state-of-the-art tracking and data management technologies. This initiative was created in 2017. In 2016, Utah was the fastest growing nation in the state. And as you all know, as population grows, that can lead to greater fragmentation of habitats. That leads to more people on the highways. And so we wanted to make sure as a state that we had the best data we could for our wildlife populations so that we could manage them most effectively. This is a screenshot of our Wildlife Migration Initiative. It was taken a few months ago, but I just wanted to show the immense amount of data that we are collecting as a state. We've tracked close to 7,000 animals and have more than 26 million locations that we can use to help us manage wildlife and determine how they're using the landscape. One of the technologies that we use to track animals is fitting them with small GPS devices. These collars track locations within a few feet multiple times throughout the day, and we can use this tracking information to describe an animal's habitat use, identify migration corridors, and identify barriers to movement. This example here is showing a cow elk and how she used the wildlife crossing structure that we'll be talking about today. Another important thing with these collars that we can collect is information to use in models to determine corridors and migration areas for wildlife. And these can be especially useful for land use planning as they highlight the areas that facilitate the movement of large numbers of animals. So this is the area of the project that I'm talking about. It's in the southeastern corner of the state, and you can see it shows up bright red on the map as an important area for migration of big game in the state. So wildlife crossing structures, as many of you I'm sure know, are bridges or culverts that are designed to move animals safely over or under roads, and these are strategically placed in locations where high numbers of animals cross busy roads. And these structures significantly reduce wildlife mortality, but most importantly, they decrease personal injury that results from wildlife vehicle collisions and reduce things like damage to vehicles. So one of the technologies we used to start the project on Highway 191 in southeastern Utah was our wildlife vehicle collision data collector. And so this is a smartphone-based app where people can go record carcasses that are being removed from the highway. Our Utah Department of Transportation hires contractors in these critical areas of road to remove wildlife carcasses, and they're able to document what types of wildlife are being used or removed from the highways. As you can see in this map on the left, in that southeastern corner of the state that we're talking about, that showed up as a bright red hotspot. And when we looked at wildlife vehicle collisions in relation to average annual daily traffic, this was one of the highest collision areas in the state. We looked at over a 20 miles or a 32-mile stretch of highway, and we found that 54% of the wildlife crossing or wildlife vehicle collisions were occurring within an 8-mile stretch. And so we targeted that for our project area. This is the data of big game collisions that occurred in that area, and you can see that a majority of those occurred between milepost 61 and probably 74. We focused on the area between milepost 62 and 70 because that's where a majority of the collisions were occurring. And as you get closer to milepost 72, where it says Monticello on that map, That is a town. It's a city, and so as we get closer to the city, there are a lot more areas that can create gaps and um, problematic areas for wildlife to get trapped in fencing. And so we prioritized the area a little bit outside of town where we thought we could be most effective. As you can see, within the period from 2006 to 2013, over 2,200 deer were recorded in the Wildlife Vehicle Collision app. I wanted to point out that we do have some documentation of elk being hit on the highway, but this data itself is probably not enough on elk to determine the effectiveness of wildlife crossings. Elk in this area, based on their migration patterns and their numbers, fortunately aren't getting hit on the highway as often. So we have to use different metrics to determine the effectiveness of these crossing structures for elk. So we worked with the Utah Department of Transportation, local sportsmen's groups, Utah Highway Patrol, and other interested stakeholders to design a phased approach to address this issue in Monticello. So in 2016, we started the first phase of the project, which included installation of one below-grade plate pipe arch structure. And this structure was phenomenal. We monitored that structure and found that there were over 19,000 mule deer movements within the first year, and that was a 98% success rate. So that means that of all the deer that approached the structure, 98% of those crossed through and only 2% repelled. So given the success of this structure, there was a lot of interest in continuing this project. And so we were able to get a phase 2. And phase 2 included several more miles of fence, 2 below-grade plate pipe arch structures, and 1 box culvert structure for Rocky Mountain elk. We had to think about elk in this process. This is one of our premier elk herds in the state. We had to make sure that we were maintaining connectivity through elk. And this was really important because in a study that Dr. Patricia Kramer had done in Utah from the 6 years prior to 2014, she found that cow elk had proven to be the most difficult animal to motivate to move under bridges, over overpasses, and through culverts. Through her entire 6-year study, Dr. Kramer monitored 38 different wildlife crossing sites, 13 of which had elk approaches, and only one time during the winter of 2013 did a herd of cow elk pass under a bridge in the state of Utah. And so we wanted to make sure that we would take every possible approach to try and make this highway crossable for elk in this area. So this slide is really busy. Mostly what I wanted to get out of this slide to all of you was just everything that has to be considered when designing a wildlife vehicle collision or a wildlife vehicle crossing. Wow, wildlife crossing structure. So as a wildlife biologist, my main priority was finding where the wildlife were already crossing this roadway, where they were already comfortable in their natural migration area, and just trying to put a structure in that location. But there's so much more that goes into that and so many more costs that I didn't understand. Even something like traffic control is such a major cost to a project like this. And so there's a lot to consider. The engineering was super informative for me, just understanding how much road base had to be above a structure in order to be structurally sound. And so I think one note here is just to make sure that as you're designing these projects, you're really in touch with the different partners that are going to be involved in these projects, so Department of Transportation and anyone else, so that everyone's involved super early on so these things can be discussed and the engineering can happen to make these successful. Another thing I was going to mention is that we got over $750,000 for this project from the Department of Transportation's Highway Safety Funds, which was the first time that those funds had been put toward a wildlife project. So it was really important that not only for wildlife and maintaining connectivity, but also really important to make this successful because this was the first time those funds were used, and we wanted to make sure that we showed how positive it could be to use safety funds for a project like this. So this is just showing the data following the construction of the crossing structures. So that top graph, you can see at milepost 68, that was the structure that we installed in 2016 that was so successful for mule deer. You can see that collisions reduced almost immediately. And then you can see throughout that entire 8-mile stretch of highway, collisions have reduced through time and they continue to decrease, and we're super excited to see that. That map on the right shows wildlife vehicle collisions by milepost. And so they're kind of difficult to see, but the wildlife crossing structures are mapped. They're the yellow diamonds with the deer in them. At milepost 68, that's the structure that was installed in 2016, so you can see how collisions reduced there. And then there are 3 more structures that are to the south and west, milepost 67, 65, and 63 roughly. Those were installed in 2019, and so hopefully that can help you kind of interpret that map if you can see that. Some things I were going to mention is, as with any project, there are unexpected things that happen. One thing was that we had an extremely heavy snow event, which led to a lot of deer stacking up along the highway before they really had an understanding of where these crossing structures were. And to the public, there was a lot of concern. And so people were opening gates and letting wildlife onto the roadway to try and let them cross, and just trying to get the message across that it takes time for animals to learn these things, and trying to balance that with making sure that we weren't causing additional mortality because of this snow event. Another issue that happened is, for some reason during construction of the project in 2019, the fencing was completely installed before the wildlife crossing structures were complete, and so wildlife ended up being stuck along the fence without anywhere to get through. One thing I did want to mention about the elk crossing structure, that is the structure at roughly milepost 63. And the dimensions of that are 14 feet tall, 26 feet wide, and 54 feet long. And so we were able to put it across a section of the road that was only 2 lanes wide. And so we were able to keep that relatively short, which I think was super important for this project to be successful. This just shows a cow elk and her GPS points as she encountered this wildlife crossing structure. You can see in the spring of 2020, she walked up and down the fence numerous times trying to look for a way to get through, wasn't able to, and ended up going clear around the end of the fence to get to her summer range. And you can see in the spring of 2021, she was able to find the crossing location eventually. She still had some issues where she was walking up and down the fence, but she was able to find the crossing structure and go through. This video shows an elk and her collar and just how she interacted with that crossing structure. She's on her winter range there, and you can see she uses the structure to go up to her summer range. So this collar data is super important for us to understand how they're using that structure. And one thing that's interesting to me is just how quickly she went through that structure and went up to her summer range once she decided to migrate. This video is showing a different technology that we use. This is called a live view camera. It's something the Department of Transportation allowed us to use. And we use this in conjunction with our elk collars. These cameras are rolling 24 hours a day. They record video, and so we're able to use the collars to understand when the elk are at the structure, and then we can look at the video to see how they're interacting with the structure. And so you can see that the elk are going to the structure, they're really nervous, they get repelled every time a vehicle drives by, and so it was really interesting to see how they interacted with the structure the first year. This is another technology that we've been documenting use on. Again, you can see a collared elk just went through there. This is just a game camera on the structure, but you can see by the second time they interacted with this structure, or the second spring, we documented use of elk 19 separate days from April 1st to May 9th. So we were really excited to see that this project was so successful so early on. I wouldn't recommend that a box culvert be used in every situation, but we were excited to see that having one in the right location and the right dimensions, that it could be successful. And so if anyone has any questions about this project or the Wildlife Migration Initiative and the technology we're using for that, please let me know. Thank you for your time. And thank you to all of our partners.